Hey teachers, so my name is Mr. Fear and I teach AP Microeconomics. I have taught AP Macroeconomics and regular economics, and this tutorial here follows the Mankiw book. You could do it right when you get into essentially perfect competition, right when you realize that the marginal revenue curve is completely horizontal, and then all of your cost curve stuff from chapter 13 if you follow that format. There's nothing additional that I'm putting here in this activity. And it's a good activity for learning some basic spreadsheet skills, as well as applying what they know and really seeing the relationship between all of these terms on a graph in the spreadsheet. So let me give you some helpful tips for helping students as they start this project. And then also we can go over what all of the answers would end up being. So our answer submissions can be found in this tab to the left here. This is where students can actually respond to all of these questions. And these might change in the future, but this is what I have for now. And then the spreadsheet is what they'll be working through. And as they work through filling in these answers, there should be a graph that populates that looks just like the graphs that they've been graphing in class. Okay, so first, let's look at total product. We're given marginal product, and total product is just the total, while marginal product is the change. And obviously we start at 0 if we have 0 workers working for our window cleaning company. So to find our total product with 1 worker, it's just going to end up being equal to this cell right here for marginal product. Now, in finding total product, a lot of your students are probably used to doing this thing, but how we could put in an answer for a spreadsheet that will make it solve for all of the following cells for us, we can write plus, and we can click on the cell above what we are solving for. So in this case, equals C3, what worker number 1 added, plus everything that came before that worker. And if I click enter, I might get this autofill suggestion, but if not, a useful tool for you to help your students is if you go to this corner, on Excel you can just double click. Oh, I guess you can do that on Google Sheets too, but you can just double click and it'll fill every row that it looks like you've entered in some data. But you can also drag this corner down through your 10 workers, and now that gives us our total product. Okay, now fixed cost. Hopefully your students keep in mind that fixed cost is fixed because it doesn't change with output. So for this one, since it's just a number, we can drag and it'll stay constant at $10 as our fixed output. Okay, this variable is already filled in. This one will correct itself. It refers back to, I guess that one doesn't, but this refers back to how many windows are being cleaned. So this all answers. And then the main thing is total wage here is just going to be how much in total you're paying all of your workers per hour. So if you have 1 worker, you're paying them $16 an hour, and we're assuming that all of our workers are paid the same. So here, 2 workers would be $32, and you could calculate it just by hand doing it that way. But you could also have students take $16, their wage, times the amount of workers that are working over here in that column. So if I click enter, that'll give me 32, and it gives me the correct numbers for everything else here. Okay, now total cost. We've got variable cost here. This is found, I think I should have deleted this, but oh, wait a second. Let's delete that. I'm not even sure that was correct. So variable cost here is how much your costs that change with output end up changing. So I'm going to use the sum function. So you put equals and then sum. And rather than referencing values I through j or whatever, we're just picking the cells that we're totaling up together. So gas is a variable cost, supplies per hour is a variable cost, and wages are a variable cost. So if you just drag with the left click these 3 cells, it'll fill it in right there. That is what you're finding the sum of. And then you can close your bracket, hit enter, and that's another way to answer for all of these. Now, the nice thing about dragging and selecting in that way is if I'm referencing and using this formula, I can again take that corner and I can fill the rest of my table, and that will give me my variable cost. Okay, now total cost. Total cost is fixed cost plus variable cost, so you can write equals and you can click on fixed cost. But then here, if you're trying to add 2 different cells, you can just use your addition symbol. So fixed cost plus variable cost in this row of 0 workers. And you can click enter and that will give you your answer. Then as you drag this down,
you can look in and you can see, okay, where did the 187 come from? And it'll say, okay, you've got this orange function here, D12 plus this purple one, H12, and that gives you the correct answer. Okay, now average fixed cost. For these ones, they are all divided by output. Your output's 0 here, and so you'd get like an error term, or, NA, can't solve for it for these 4 functions. So I've left them as a hyphen, but then we can start solving once we have some output produced. And then we also aren't ever going to produce where we have negative marginal returns here. So just know that I've included those so that you can see negative marginal returns, but when we're graphing our per unit cost curves, you never get that far to the right on the graph. And so this table, as it's populated, it'll end before that happens for what I've chosen for it to reference. Okay, average fixed cost. For this one, this is your fixed cost divided by your amount of output. And a lot of students struggle with this. They're probably going to choose amount of workers, your quantity of inputs, but we're looking at total product here, which is just your quantity. If we're talking about a price and quantity supply demand function, total output is what we're looking for. So this function is the most complicated one, which is why there's a little bit of a clue, some clues down here for different types of equations. But we're going to use equals, and I'm going to start a parenthesis so that our order of operations stays correct. But, oh, actually, we don't need to do that. We're going to reference our fixed costs, okay, because average fixed cost is fixed cost divided by our quantity of output, and then divided by can be that / found right below the question mark for me. And then we're just dividing it by our output, which in this case are 4 windows cleaned per hour. If I hit enter, that gives me I'll click this one this time. That gives me my average fixed cost. And what you can see now is we've got an average fixed cost curve that looks as it should. It increasingly gets closer and closer to 0 as output increases. Okay, now average variable cost. That's going to be your variable cost divided by your amount of output. So we can kind of do the same. We can hit equals. We can select variable cost, and then we can hit divide, and then total product per hour, enter, and that gives us our average variable cost curve. Now, if your students don't enter in the product for all this, your curves will look pretty weird. I'll just show you what that looks like right now. And that's they actually can't divide. That's a giveaway that they've maybe done something a little bit wrong. So this graph here, you might not even grade this graph, but it is useful for students to check their work because they should know what an ATC, AVC, AFC curve should look like. Okay, now average total cost. You could calculate this a very complicated way, but I'm going to go back to using my sum function because ATC equals AFC plus AVC. Highlight those two, close the bracket, and it'll autofill, and we've got this nice looking green ATC curve that is as high above AVC is as AFC is above 0. Okay, and then marginal cost. This one's complicated. Before we get there, you see this awkward looking curve right here. Marginal revenue for a perfectly competitive firm is completely horizontal. I've titled this a perfectly competitive window cleaner just so that we can kind of simplify and learn marginal revenue in that way, as well as learn the shutdown point, producing at a loss, producing at profits, break-even points. And so for this, 558 is Mr. DARP. It's your marginal revenue, your average revenue, your demand, and your price. And so that's going to fill in for $5.58 for all of them. And we see now that MR curve that's going across our cost curves. Okay, now marginal cost. This one is a little bit complicated. So marginal cost is your change in total cost over your change in outputs. Fortunately, you're already given a change in output, which in this case is marginal product per hour. Okay, but now your change in total cost, that's where things are going to get a little complicated. So I'm going to start a bracket. I'm going to select total cost here minus the cell above it. So that would tell me how much my total cost is changing by. Now I'm going to close my bracket. I'm going to divide that answer, which is my change in total cost, by my change in output, which fortunately we've already calculated as marginal product. I'm going to hit enter, and that will now give me all of my marginal costs. And it creates this nice red marginal cost curve that crosses AVC at its minimum, crosses ATC at its minimum, and tells me a pretty clear profit maximizing point. Okay, now we can start looking at all these questions. At what price per window should the company stop operations? Okay, so for this one, the numbers aren't super duper clear, but your students should know that they're looking for the minimum of AVC. Okay, so as I look at AVC, my smallest number that I get here is 3.05 because it's bigger than that before, smaller afterwards, and that looks like it's at 23 windows. So $3.05. If the price that I can get per window is lower than that, and let's just display this quick. And it might not look perfect on the graph since we can't have fractions of workers and whatnot, but it's pretty close. My marginal revenue crossing my marginal cost, it all kind of crosses at the minimum of AVC. So that is your shutdown point. And then the next question sort of references that, but it's at between what two prices should the company continue to operate despite being at an economic loss? So that's going to be that that $3.05 is above that. It's still better to operate, still better to produce things, because you're having less of a loss than if you just pay your fixed costs and don't produce anything. But you're still operating at a loss, so it's between $3.05 per window, and then it's going to be your minimum of your ATC, because that's going to be your break-even point. So anything below that, you're operating at a loss. So if we just look at our ATC here, the smallest number we can find is all we're looking for. We're not getting too fancy. It looks like it is, going to be $3.49. And yeah, this is a little bit imperfect, because if we're looking at our table, this is a little bit different than that number. It's a little bit different of an output, but all this question is asking for is between what two prices are we operating at a loss. So here, $3.49 is the minimum of my ATC. And if we plot it here, yeah, it looks like it's somewhat hitting the minimum of my ATC. Okay, and then 5, at what price would they start making a profit? That's just the top end of that. So really these questions 2 through 4, question 3 is basically both of the questions, but it shows you where those ranges and where those changes happen depending on what's going to happen with price there. Okay, now 5, what is the profit maximizing amount of windows at $5.58? This is given at the start of the activity for this formula in this cell. So 558 puts you here. That pretty clearly on our graph is crossing at 35 windows. But also if we look here, these marginal cost and marginal revenue are equal to each other. Now they're equal to each other at an output of 35 windows. So that would be the answer to question number 5. Okay, 6, what would happen to the profit maximizing amount of windows cleaned if fixed costs per hour increased from $10 to $20? Okay, so it says increase to $20. So for that, I've got everything as it should be set. I can edit my fixed costs per hour, and if I calculated all these correctly and linked them, which is why it's nice to practice your spreadsheet skills, that's going to shift all of my curves automatically. Okay, now what you'll notice is, same thing with theory, if you change your fixed costs, your profitability changes, but not your output. So you're maximizing output still where MR crosses MC, and that is still at 35 units. Okay, so now we'll go back and we'll change that again because a later question asks it, but for this next one it says assume that they're $10 again, so I'm going to change them all back to $10, shifting my curves down. And what I like about this activity is you see the graph change as you change numbers. So practicing shifts, you actually see that shift occur. Assume fixed costs are $10 again. What would happen to the profit maximizing amount of windows if wages increase to $21.30 per hour? Okay, so now my wages are total wage cost per hour. This one is 16. I'm going to change it to $21.30. Whoops. Got to get my equal sign in there. Times my amount of workers. And this could be that same formula too. And as I multiply this down, I see that shift occurring. Okay, so I'm paying each of these workers $21.30. That checks out. But now my marginal cost has changed. All right, so I still want to produce where MR crosses MC, and now MR crosses MC at 32 windows. And here we can also see that. This is 32 windows. We're still profitable economically speaking, but MR and MC, I should now try to clean 32 windows per hour rather than 35. Okay, 8. Okay, by how much in total does economic profit decrease? These are kind of the extension problems, but good practicing for total answers. By how much in total does economic profit decrease if the price per window cleaned is $5.58 and the fixed cost per hour increased from $10 to $20. Okay, so now we have to find that change with that. So wages, I'm going to put wages back at $16. Drag this down. Okay, now my fixed costs. What I should do first is I should try to figure out what my economic profit is prior to changing my fixed costs. So I'm producing at my profit maximizing quantity here of 35 windows. At 35 windows, my ATC, or my average total cost, is $3.76. So what I could do is I could just subtract my $5.58 here minus my $3.76 and then multiply it by 35. Okay, and that would give me my answer, and let's just do that really quick to the side here. So 558 minus 376, and let's put it in brackets. Okay, and then we got to multiply by our quantity, which is 35 units. And that will give us an answer of $63.70 per hour of profit is what we're starting with. Okay, but now we've got to change things. So our fixed costs now, and the other way to multiply this is you multiply your marginal revenue times 35, and then you multiply your ATC times 35 to get your total revenue and your total ATC. And the difference between those two will still be $63.70. Okay, so now fixed costs, we've got to change them. And we have to see how our profitability changes. Your marginal revenue or your total revenue will be the same at 558 times 35. But now, okay, 35 units, our ATC is $4.05. So we have to calculate the difference between 558 minus $4.05. And we are still producing 35 cleaned windows. Our answer is 53.55 in total, and now we have to find the difference and show the decrease in profitability. I'll make it a negative number since it's a decrease. So this minus that gives us an answer of we have lost $10.15 per hour of economic profit as a result of that change. Okay, now the fun one. I guess I'll leave that there. We got to put fixed costs back at $10. Our wages are going from $16 to $21.30, and we want to see how our profitability is changing. So the good news is our profitability is still the same here. This is our total economic profit with $10 and $16 for wages. So now we're going to change this to $21.30. Going to drag this to apply it to every worker. Everyone's getting a wage raise. Okay, but now something to keep in mind, actually my profitability has changed. Let me backtrack with what I said there, is now our amount of windows cleaned is 32. So we do have to be careful here, very careful. Okay, so actually, no, I lied. We're producing at a different amount. That was our revenue at $16.10 because 35 windows was how much we wanted then. Okay, it can be a little complicated, but the spreadsheet kind of helps as guide rails. Okay, so after that wage raise, we are going to have a marginal revenue of $5.58 still. But now we're going to subtract where MR crosses MC, right here, our average total cost, which is now $4.59. Okay, but now keep in mind we are not producing 35 windows per hour. We are cleaning 32 windows per hour because our MRMC has changed. They are equal here now, which is at 32 windows. So when I click enter, now it's 31.68. So our new, or how much our economic profit has decreased, is going to be 31.68 minus our original amount of economic profit. That gives us a decrease of $32.02 per hour for total economic loss as a result of that increase in wage raise. Okay, now these last two questions are kind of tough. Even I stumbled with them a little bit. So those are kind of your extra questions, your challenge questions for students that might have finished the other steps a little bit earlier.
than prior students. But this is the activity. I'd like some feedback on it. So if you're interested in trying it out, let me know how it goes, and I can edit some things as we go, maybe to play with the numbers, but I'd like to see how students do with this. And it's also a good intro for learning some of the functions that they have to use to make their lives a lot easier with this graph. So let me know what you think. Thanks.